although very small amounts of liquid water may occur transiently on the surface of Mars, limited to traces of dissolved moisture from the atmosphere and thin films. Large quantities of ice are present on and under the surface. Small amounts of water vapor are present in the atmosphere, and liquid water may be present under the surface. In addition, a large quantity of liquid water was likely present on the surface in the distant past. Currently, ice is mostly present in polar permafrost. More than 5 million km3 of ice have been detected at or near the surface of Mars, enough to cover the planet to a depth of 35 meters, 115 ft. Even more ice might be locked away in the deep subsurface. The chemical signature of water vapor on Mars was first unequivocally demonstrated in 1963 by spectroscopy using an Earth-based telescope. In 2008 and 2013, ice was detected in soil samples taken by the Phoenix lander and Curiosity rover. In 2018, radar findings suggested the presence of liquid water in subglacial lakes. And in 2024, seismometer data suggested the presence of liquid water deep under the surface. Most of the ice on Mars is buried. However, ice is present at the surface at several locations. In the mid-latitudes, surface ice is present in impact craters, steep scarps, and gullies. At latitudes near the poles, ice is present in glaciers. Ice is visible at the surface at the North Polar ice cap, and abundant ice is present beneath the permanent carbon dioxide ice cap at the Martian South Pole. The present-day inventory of water on Mars can be estimated from spacecraft images, remote sensing techniques, spectroscopic measurements, ground-penetrating radar, etc., and surface investigations from landers and rovers, including X-ray spectroscopy, neutron spectroscopy, and seismography. Before about 3.8 billion years ago, Mars may have had a denser atmosphere and higher surface temperatures, potentially allowing greater amounts of liquid water on the surface, possibly including a large ocean that may have covered 1/3 of the planet. Water has also apparently flowed across the surface for short periods at various intervals, more recently in Mars's history. Iali's Palace in Gale Crater, explored by the Curiosity rover, is the geological remains of an ancient freshwater lake that could have been a hospitable environment for microbial life. Geologic evidence of past water includes enormous outflow channels carved by floods, ancient river valley networks, deltas, and lake beds, and the detection of rocks and minerals on the surface that could only have formed in liquid water. Numerous geomorphic features suggest the presence of ground ice permafrost and the movement of ice in glaciers, both in the recent past and present. Gullies and slope lineae along cliffs and crater walls suggest that flowing water may continue to shape the surface of Mars. Although what was thought to be low-volume liquid brines in shallow Martian soil, also called recurrent slope lineae, may be grains of flowing sand and dust slipping downhill to make dark streaks. although the surface of Mars was periodically wet and could have been hospitable to microbial life billions of years ago. No definite evidence of life, past or present, has been found on Mars. The best potential locations for discovering life on Mars may be in subsurface environments. A large amount of underground ice, equivalent to the volume of water in Lake Superior, has been found under Utopia Planitia. In 2018, based on radar data, scientists reported the discovery of a possible subglacial lake on Mars, 1.5 km, 0.93 mi, below the southern polar ice cap, with a horizontal extent of about 20 km, 12 mi. Findings that were strengthened by additional radar findings in September 2020, although subsequent work has questioned this detection. Understanding the extent and situation of water on Mars is important to assess the planet's potential for harboring life and for providing usable resources for future human exploration. For this reason, Follow the Water was the science theme of NASA's Mars Exploration Program, MEP. In the first decade of the 21st century, NASA and ESA missions, including 2001 Mars Odyssey, Mars Express, Mars Exploration Rovers, MERS, Mars Reconnaissance Orbiter, MRO, and Mars Phoenix Lander, have provided information about water's abundance and distribution on Mars. Mars Odyssey, Mars Express, MRO, and Mars Science Lander Curiosity rover are still operating, and discoveries continue to be made. In August 2024, researchers reported that analysis of seismic data from NASA's InSight Mars lander suggested the presence of a reservoir of liquid water at depths of 10-20 kilometers, 6 to 12, 4 mi, under the Martian crust.